Hi, and welcome to an introduction to the TIPS well log modeler. In this video, I'm just going to give you a real quick brief overview of the software interface and kind of make sure you understand the objectives of what we're trying to accomplish with the software and the kind of the theory behind the software layout. We're not going to get into too much of actually doing importing well logs and creating synthetics. We're just going to give a brief introduction. When you fire up the TIPS well log modeler, you'll see this interface in front of you. Across the top is the banner that tells you obviously the name of the application, then a menu bar of all the categories of operations that you can perform. We have a tree over on the left, which is broken down. At the top level is our project. It's a well-centric project. So we're bringing in one well, and we're going to analyze and modify and create all types of models for that particular well. Underneath the well, we break down the data by log data. These can be all of our LAS curves that we pull in. We have custom curves, and these are curves that we can create based on the log data that's in the LAS file. And then we have a seismic data node. So when we're ready to do well ties, we can pull in seismic data and generate that. As we bring in files to create this tree, will grow and expand. The big area in the middle are for our well log curves. And so as we go to draw the parameters as a function of depth for sonic, P-wave, resistivity, shale volume, so on and so forth, they'll show up here. And there's a lot of functionality that we can add to it here. We've got a little shortcut ribbon across the top to do file project, new project, open and save it, importing an LAS file and the like. Now down at the very bottom is what we call the status bar. This tells us our version, a date. We'll have information that will fill in here based upon the data that we bring in. And the little green light, yellow light that kind of gives us, if we see it yellow or red, then we're probably missing some information. So when we go to run the well log model, the first thing we want to do is import an LAS file. Now, you can hopefully see across the top that I've got something that says LAS data. That would be my first clue that that's where I need to start. So I'm going to go to LAS data, and I can say add LAS file. Okay, you might get all excited and say, oh, I really want to come over and create synthetics, and I'm going to click on synthetics. Oh, I want to do AVO models. Well, it's going to tell you you don't have any information yet. So we're going to add an LAS file. This is the first thing we want to do. And when I click on this, it's going to take us to a typical file browser, and I'm going to pick a file, and then wherever I have an LAS file, I'm going to click on it, and it's going to pull it in just like that. It's read that, and you can see our tree has expanded here. So under the LAS file, we have all of these curves, and these are, at this point, they're like placeholders based on all the mnemonics that are in the well log data. Information about the LAS file is there. So now the great thing about this tree is we can click on a node, and there's shortcuts. Anything you want to do, you can handle up here. LAS data, I can look at the LAS data properties, and I can click on that. And this is going to tell me what version it is, what the depth mnemonic is, so on and so forth. Information that it's pulled from there. Or just as easily, I could right mouse on that node and say properties, and I get the same information. So I get these shortcuts. As of right now, TIPS knows that I've got an LAS file in there, and that I have a bunch of these curves. You'll also notice at the top, instead of at the very root node, it pulls the name of the well from the LAS file and puts it in there. We could change that if we wanted to, but for now we're just going to use what's in the LAS file. So before we do anything, we need to be able to make sure that TIPS knows what these mnemonics are. We need to make sure we know their units and what actual log parameters they're assigned to. So the way we do this is we click on a curve in here, and if I hold my mouse over, you see this little yellow flag next to it. What that's telling me is no TIPS parameter has been assigned. So you need to edit the node properties. So again, the only thing TIPS knows at this point is that there's something in there called DT. It doesn't know what it is. So when I can click on it, and I can go to the top where I can go to curves, and I can hit properties. Okay, curve is anything shown in the LAS file, and then custom curves when we get to that. or I can right mouse on it and say properties. Okay, so now this tells me I've got a data curve. Several of these fields are shown in read only because they're not modifiable. So the mnemonic is DT, and I'm going to come down to the bottom a second, and this, what it's read from the LAS data is that its units per the LAS file are US/F, which is probably microseconds per feet. The description that it's pulled in is sonic, and then we've computed the range of data, 51 to 188, and that's important for a moment. But these, as you know, these are different on every LAS file. There really isn't a standard that we can apply. So what we need to do is tell TIPS what parameter, well log parameter is DT. Well, we know looking at this that this is a sonic, so I'm going to hit the drop down next to the parameter. And all of these parameters listed are parameters that TIPS knows about. And I'm going to scroll down here until I see one that says sonic. Then this is very important. The units. What units is it? Well, sonic can be either microseconds per feet or microseconds per meter. Well, even though this says microseconds per feet, this data range is really handy because I can look at that and I know that I've done this, that if its values are going from 51 to 186, it's more than likely it is in microseconds per feet. So I'm going to pull that, identify this DT as a sonic curve, and it's in microseconds per feet. If we want to display and work in meters later, not a problem, but we need to know what the units are when we first come in. So when I hit accept, we'll notice that now it says sonic parentheses DT. Sonic means this is a TIPS parameter. I'm ready to work with this as a sonic, and its source is that mnemonic DT. Now, our yellow flag is still there. If we hold our mouse over this, it says it contains missing data. You might want to fill that. We'll come back to that in a moment, but for now, I'm going to pick some of these other parameters and I'm going to assign it to it. Like, let's go to the next one, GR, and I right mouse and hit properties, and I look at that. Oh, that's a gamma ray. And I'm going to scroll down and say, all right, TIPS, here's gamma. Its only units are API. And you can see how that's changed. And I'm going to skip all these. We don't have to assign all of them. And phi, I'm going to look at that, and that is a neutron porosity. So I'll scroll down and up, tell TIPS your neutron porosity. Now here's the one to pay attention to. Its units. Is it decimal or percentage? So its range is 7 to 70, not 0.7 to 0.6. If it were 0.7 to 0.6, the units would be decimal. Since it's 7 to 60, that we know it's actually in percentage. That's important later. So now we have a neutron porosity. I'm going to repeat this for a couple as you can see where we're going with this. And this is one of the more time-consuming parts of the modeling process. So that's a bulk density, SP. I'm going to look at that. That's spontaneous potential in this case, right there. It's in millivolts, and I hit accept. Okay, now the great thing is if I save this project and then reopen it, I'm going to be right back where we are. So it's a good. So I've done this. I've gone to this, a little bit of a tedious task in identifying these parameters. I don't have to do them all. I just have to do the ones that are going to be important for me to describe this well log to be able to create synthetics. So I can hit File, Save, and I'm going to give it a name, and I'm going to call this Intro Project. Okay. Oop. Okay. So now it has saved this project. So if I close and restore, it comes back right where we are right now. Now we want to look at some curves. So the best way to look at the curves, I can, again, right mouse on any one of these. I can hit properties and hit show curves. And when I do that, it's shown. Now it's just showing the one curve here. And I'm going to go through the dynamic controls of that. But the thing that I like to do is come up here to View, Chart Layout. Okay, here are the available curves. These are the ones that we've identified. And I can put, these are the available, and these are the ones that have been selected to display. I can move these over. I can click on one and then click on the arrow to do that. Or I can double click and that will move these over. Then once over here, I can move them up and down. Let's say I want my sonic bulk density. This is going to be my left to right display. When I hit accept, all of a sudden I have all of these curves. Now real quick, before, and I'm going to stop this video right after I do this, we'll do some of the view controls right now. If you use your mouse wheel, it will scroll up and down. Little toolbar across here. This is a dynamic zoom, and if I click on this, I then drag a window. Okay, and I've zoomed into there. Now if I use my mouse wheel, you can see I'm scrolling up and scrolling down. If I zoom in, it's zooming in time, and zoom out in time. If I do zoom all, that's going to zoom everything that was read into the LAS file. So from the top of the well log to the bottom. And I have a scroll up and down button as well as a hand button. I can click and drag in these charts. When we come back, we're going to talk about how we can manipulate the scales and the properties of the charts that are shown and the colors and all of that. And then we're going to get into addressing these big pink areas in here, which, as you probably guessed, are missing data. One last thing I'm going to note over on the tree, the only one that doesn't have a flag is resistivity. Okay, and if I look at the curve, resistivity doesn't have any pink regions. The others have pink regions, and they do have the flags because I'm missing data. So that gives you a little clue of what's going to be in the next video.